This is a little bit different of a problem. We need to solve this exponential equation. But the problem is that we have this one, this side here has a base 3, and this side here has a base 2. So it's normally, or I shouldn't say normally, but in the past when we were looking at solving exponential equations, we could take a logarithm of both sides. So we would take a log 3 of this side here, which would then bring our exponent down, and this would have the same base, so take a log 3 of this side here, and that would bring our exponent down. But that is not the case here. I have two different bases. What am I going to do? Well, what I'm going to do here is I'm going to use the power property of logarithms. So you'll see momentarily. What I'm going to do is I'm going to take a common log of both sides. So that's a log base 10. So I have log 3x plus 1. And since I do it to one side, I have to do it to both sides. So log 2 to the 4x. So I took my logarithm of both sides of the equation. But what that does now is I have, let's make it a different color. I have a power that I'm taking a logarithm of. See, right here, I'm taking a power of that. So I can rewrite this as x plus 1 log 3 is equal to 4x log 2. I've taken my power now and moved it to the front. I've changed my power into a factor. That's what the power property says. The power property says that log x squared is the same as 2 log x. We take the exponent and we turn it into a factor. Now I think the problem becomes a lot easier to solve, because log 3 is the same thing as log 10 base 3, and log 2 is the same thing as log 10 base 2. Those are just numbers. They're exponents, but they're the numbers on 10. They're the exponents on 10 that would give us 3 or 2. They're going to be actual real numbers. So I'm going to rewrite this just so you can see it a little bit more clearly. I have x plus 1 times log 3 is equal to 4x, let's make it equal to so it looks like that, equal to 4x times log 2. I made the exponents into factors. Well, now I'm going to aggregate my x's on one side and my logs on the other, because again, log 3 and log 2 are simply numbers. So I'm going to have x plus 1 divided by 4x. I divided both sides of the equation by 4x. And that's going to be equal to log 2 divided by log 3. Now again, remember, log 2 and log 3, they're simply numbers. I can tell you right now, I'm going to put it into my calculator. Log 2 is approximately equal to 0.301. And log 3 is approximately equal to 0.477. Let's just show you how I did that. I just called up my calculator, and so I have log 2, 0.301. I have log 3, 0.477, and I'm going to divide log 2 by log 3. And I can just do that easily with the calculator. I can go log 2 divided by log 3. And that gives me 0.6309. Let's write that down here. That is equal to, I need a pen here, 0.631. We'll round it off to 3 decimals. I just want to show you something else. What if I decide instead of using the common log, which is base 10, I want to take ln. I go ln of 2, and I divide it by ln of 3. What am I going to get? Amazing, I get the same answer. That's because I'm just doing the same thing to both sides of the equation. It doesn't matter whether it's log 10 or log e or log 8. As long as I'm doing the same log, I'm going to get the same answer. The ratio of the two logs is going to be the same. So back to my equation, I have x plus 1 divided by 4x is equal to 0.631, approximately equal. Did you know you can make it with a dot sign over it as opposed to the squiggly lines? It means the same thing. So now I'm going to solve this. I'm going to have x plus 1. I'll make it approximately equal to 0.631 times 4x. X plus 1 is approximately equal to, I'm just going to multiply my 0.631 times my 4, and I'm going to get 2.524x. I think I will subtract 1 from both sides. I'm sorry, I won't do that. I'm going to subtract x from both sides. So I consolidate my x's on both sides of the equation. I have 1 is approximately equal to 1.524x. And now if I divide both sides by 1.524, I get x is approximately equal to 1 divided by 1.524 0.656, which is in fact the answer.